need from you. So watch that. Okay, here we go, 6.4. So let me just say something before I start. We're going to do logs for probably 2.5 weeks. It's a big part of this class. And sometimes I'll give a test or a quiz and I'll say to myself, this person is really confused. I wish I could just start over. And this is really where I would start over, right here. So today's kind of like the foundation. So just make sure you really understand today. I'm not going to go crazy fast because then I'm going to confuse you and then your foundation is not going to be solid. So, I'll try to be steady, but I'm not going to push too hard because you've got to understand this. Okay. So everything inside that box, you've absolutely got to be able to do very, very well. It's just converting from exponential to log, okay? So everybody look right here. If I have 2 to the 3rd power, tell me what the base is on 2 to the 3rd.
2.
It's the 2, okay? So if you look at exponential form right here, guys, everybody, don't go ahead of me, just no writing, just kind of chill, make sure you get this foundation. If you're 3 problems ahead of me, are you listening to what I'm saying to you? Yes or no? No, you're not. And do I know all the little tricks and expectations that Weber has of you? Yes. So if you're 3 ahead of me, you're missing the whole thing. So it's pointless. You're just shooting yourself in the foot. Okay, let's go back to exponential form. Okay, you guys told me that the 2 is the base. So the base right there is the b. Okay, so when you take that exponential and you put it in log form, the base stays a base. So the way that you say this over here in the log, guys, it's log base b. So the base over here is the base over here, okay? And then what you do is you say of the other side, which is an x, is equal to, the only thing I haven't written yet is a y. When you go the other way, you take the base, which is a b, and you write it down, and you raise it to the other side, which is a y, is equal to the only thing we haven't written down yet. Okay, so let's go ahead with A. Everybody in the room, tell me what is the base in that problem? 5. And then you raise it to the other side, which is a 2. And then you put equals. What's the only thing we haven't written yet? An x. Okay, now I want you to underneath that write x equals 25. And then I don't want you to scribble it. I want you to still be able to read it, but I want you to put an X through it. So when you go through your workbook, you're like, oh yeah, don't simplify it. Because if you simplify that, guys, it's not in exponential form anymore because you evaluated it, okay? Everybody look at question B. Tell me the base. 4 raised to the, talk to me, everybody. 3rd is equal to, talk to me, 64. Very easy, very quick, right? Okay, next one, base, tell me. 5, everybody tell me, to the what? 2nd, I can't hear your voices, equals, tell me. 25, good, next one. Base is, what's the first thing I write? 7 to the 0 equals 1, good. Was this highlighted that it's on the final?
Yes.
Okay, and when I get to the particular problem, let me know so I can just really kind of emphasize that, okay? Okay, now we're going to go the other way. Everybody look at the problem, and everyone in the room, there are like 35 people in this room. Tell me what my base is. It's a 6. So we're going to go log base 6 of the other side, which is a 1, is equal to 0. Now I want everyone to look forward. Please look forward right now. I am very picky about this because I know Weber's going to be picky about this. If you write it like this, you will get nothing. The 1 is not an exponent. The 1 is on the same level as the log. The 6 is subscript. It's down below. So you've got to be really careful with your placement of these numbers, okay? Okay, let's do the next one. Everybody go log base what, everybody? 5 of, keep talking to me, 25 is equal to, what haven't I written? 2. This is easy, right? Easy, guys? Yes. Okay, this is log base, tell me, 4 of 16 equals x. Yep, make sure you're getting this down, okay?
Light work.
Say it again.
Light work.
Yes. Okay, this one, we're still writing it in log form. Yep. Okay, this is log base 3 of, talk to me, 1 over 81 is equal to -4. Now I want you to look forward for a second. If you wrote your answer like that, it would be totally acceptable. I wouldn't write it like that because what I'm taking the log of is starting to get complicated because it's a fraction. So if it ever starts to get complicated, I always throw parentheses around it just to be very clear that I'm taking the log of that whole thing, okay? You don't have to, but I think it's a good idea, okay? Okay, this one right here, this is log base 5 of, tell me, 1 over 125, and I'm going to put parentheses around that is equal to 2x, okay? Freeze for 2 seconds. If they wanted me to solve for x, which that's not what they're asking, how would I solve for x? What would I do? How do I get the x alone? You guys are so smart, and I'm surprised I'm stumping you. If I'm trying to get the x alone, I have to get rid of the 2. What do? Divide by 2. Yeah, that would be it, okay? But that's not what they're asking. Okay, example 3, find the exact value of each log. Okay, everybody set this equal to, you know what? This is like, I feel like this is almost like out of order. Did I give you the rule for logs already? Like a bunch of rules for logs? I feel like this is so weird. Yeah, I feel weird. Just turn to page 79 for a second. I don't know if in the past I've just done this on the calculator, but let's just talk about these rules really fast, okay, right here. Okay, so off to the side, right here, I want you to write the word memorize. And we'll go back over this, obviously, when we do this lesson, okay? So the first rule is log base a of 1 equals 0. Because, guys, look, if you were converting it, you'd have a to the 0 power is equal to 1. And anything to the 0 power is always 1. So come up here to the side, and I want you to write log base 8 of 1 is 0. And then I want you to write log base 23 of 1 is 0. And then I want you to write log base 143 of 1 equals 0. Could I keep writing these all day? Yes. Log base anything of 1 is a 0. Now that's really not true. I just said log base anything of 1 is a 0. That's false. Because those numbers right now, right there that I just highlighted, can they be negative? Can you take log base -2? No, they can't be. Okay, so just be aware of that. It's not log base anything. Okay, the next one right here, log base a of a is 1. If you converted it, guys, you'd have a to the first power is equal to a. A to the first is always a. Okay, so everybody write these rules down. Write this little example. I'm just trying to show you. So if you have log base 11 of 11, that's 1. If you have log base 42 of 42, that's 1. If you have log base 572 of 572, that's 1. We could write them all day. You get the idea. Okay, next one. So this rule number 3, what I do, that's not even something to memorize for sure. If you have an exponent, you guys, just pull it down in front. So everybody write n times log base a of a. What is log base a of a equal to, everybody? Look at the rule up above. What's log base a of a equal to, guys? 1, and 1 times n is an n. So it's not really something that you even have to memorize, except just remember to bring that exponent down, okay? So this rule right here, you know, you don't have to memorize it, you just have to kind of remember it, right? And there's really not a way for me to walk you through it to remember. So everybody just write 7 raised to the log base 7 of 2r. So if this is a 7 and it's raised to the log of the same base, then your answer is actually whatever is right there. So your answer would be 2r. Okay, I'll go back over these rules very quickly on the next lesson, but I'm just trying to touch base. Okay, one last rule. Just listen to this for 2 seconds, guys. Could 2 to the third ever be equal to 2 to the ninth? Could those two things ever be equal to each other? No, one's an 8 and one's something big, right? So if I knew that 2 to the x was 2 to the ninth, then I know x would have to be what, everybody? 9. That's easy, right? Okay, so come over here and apply the same thing. So could log base 10 of 4 ever be equal to log base 10 of 17? No, because they're different. Same idea, right? So if this said log base 10 of x is log base 10 of 17, then I know x would have to be, tell me everybody, 17. Okay, same idea. Okay, now let's go back to our lesson. Sorry, I feel like I need to like reevaluate where these things are. Okay, so here we are. So you guys put it equal to x right there. And what the author is trying to get you to do is they're trying to get you to write it as log base 2 of 2. Well, if this said log base 2 of 7, could I write a 7 as a 2 to the something? No, so it would never work. But on this one, we're lucky because we can. So this is going to be log base 2 of 2 to the what, everybody? Third. 2 to the third. And I'm going to put the x equals out in front. And now I'm going to take that exponent and I'm going to pull it down in front. So I have x equals 3 times log base 2 of 2. Log base 2 of 2 is a 1. 1 times 3 is 3. That's my answer. Okay. Question B is easy. You just have to remember the rules. Log base anything of 1 is what, everybody? 0. Yep, it's a 0. Okay, look at question C. They're trying to get me to write it as log base 7 of 7. Because then log base 7 of 7 is 1. Can I write that in a minute as log base 7 of 7? Yes. I can, because how do you know that? 49 is 7 squared, right? So everybody write down log base 7 of 1 over 7 squared. But that 7 can't be on the bottom. So I've got to pull it up to the top. So it's going to be log base 7 of 7 to the, tell me, negative second. Now I'm going to pull that negative 2 in front. So I have negative 2 times log base 7 of 7. Everybody tell me what that's equal to. Negative 2 is correct. Good. Okay, let's do the next one. Everybody write log base 8 of 8. The square root of 8 is 8 to the what power, guys? It's 8 to the 1/2 power. Yep. And then you take that 1/2 and what do you do to the 1/2, everybody? Pull it in front. So it's 1/2 times log base 8 of 8. Everybody tell me what that's equal to. 1/2. Okay. Who says this is easy? I got it. If you feel a little uneasy about that, don't worry, because on the next lesson, we're going to go over that better with those examples that are right after the rules. Okay, grab your calculator. And I want you to look on the left-hand side. On the left-hand side, second button down, you've got a log button. You guys, underneath log 100, I want everybody to write log base what? There's no base there. So what is it? 10. It's log base 10. So everybody write log base 10 of 100 so that you understand that the base is a 10. Okay. On the calculator, when you hit the log button, the base is automatically 10. Okay. So everybody go log 100, close it off, hit enter, and you get a 2. That's it. Okay. Let's do the next one. ln. What is ln, you guys? Natural. Which is, how do you write it as a log? Yeah, let's write underneath it, log base E of 1.43. And what is E equal to again? Do you remember? 2.7. Yeah. Did we talk about that in here? Sorry, I'm just getting mixed up because I'm teaching the same thing to my 1010. We talked about it? Okay. So it's 2.718, blah, 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 blah. It's not scary. It's not confusing. It's not going to change. It's just this crazy number. That's all you need to know, okay? So if you hit ln and then 1.43, close it off, hit enter, you get a crazy decimal. It's called an irrational number. Well, how are you supposed to write that down? Well, the directions would tell you where to round. So we're saying that the directions said to round to 4 digits, and I get 0.3577. That's my answer, and I'm done. Okay. Look at this one. Somebody talk to me about that. What about the negative? Can you take the log? Is an ln a log, first of all? Yes, it is. It's just a log base e. Can you take the log of a negative number? You cannot. So I want you to say not possible. Please don't say no solution, because we're not solving anything. It's not x equals. It's just an expression that we're evaluating. Okay? All right, let's do question D. There's no D. A, B, C, E. Okay, so this one right here, I want you to write this down. Write down the word stuck, and then I want you to write down convert. I'm going to say that every single time we do a log lesson. When you get stuck, you convert it. So I'm trying to figure out what x is, but I can't do it. It's in log form, and I can't like divide by x. That's not mathematically accurate. So guys, this is log base 10. So all I'm going to do is just convert it into exponential. So I get 10 to the 0.7482 is equal to x. Okay, now grab your calculator and go 10 to the 0.7482, hit enter. Let's say the directions told you to round to 4 digits, so your answer would be x equals 5.6002. Done. Okay, question F. Same thing. I'm stuck. This is log base what, everybody? Log base e. So when I convert it, it's e to the 1.335 is equal to x. Okay, grab your calculator. Here's how you evaluate that. Everybody go second, then go down 2 buttons to where it says ln, and then go 1.335, close it off, hit enter. We're going to go 4 digits. I'm glad that we're going 4 digits because we can talk about this. Look at this. So it's 79999. So here's your 4th digit. The 9 tells you to go up. So the 7,999 goes up 1 to what? 8,000, right? So this would be 3 point, and then you've got 8,000, and I never require those zeros. We know it doesn't make a difference. If you wrote them, that's fine, but it's not necessary, okay? Who says I gotcha? Let me see. Okay, great. Okay, you know how we graphed exponentials last time? Now we're going to graph logs. And you know, who says this? Raise your hand if you're like, I think graphing exponentials is so easy. Raise your hand if you feel like that. We did it last time. Okay, not a ton of you. Raise your hand if you think it's tough graphing exponentials. Okay, I'm going to ask it again. Don't lie. Who thinks graphing exponentials is easy? Let me see. Raise your hand. Do a big raise all the way up to the ceiling. Okay, so that kind of scares me. Maybe you're confused with that. I don't know. We did that last time, right? Graphing exponentials. Okay. So anyway, here's a log. And your log has an asymptote that is like that. It's vertical. So one of my students said this great thing a long time ago. She said, someone was like, I don't know if the asymptote on a log is horizontal because it kind of looks like it goes flat, or if it's vertical. Well, log begins with the letter L, and that looks like a vertical line, so that can remind you that that's how the asymptote runs, okay? Okay, off to the side, I want you to write this down. Everybody go 1, 0, and then I want you to go B, 1. Those are the 2 things you have to remember. You know how you can graph an exponential in like 20 seconds? You're going to be able to graph a parent log just as quick. Right up above here, I want you to write the word parent, okay? The other thing you have to remember, look at that asymptote, you guys. It crosses the x-axis at 0. So there's your asymptote, okay? So watch how quickly I graph it. I go, okay, I got a parent, graph my asymptote, hit the 0.10. Now look at this. pencil back at the origin. That's a big place of error. People go from the dot. It's from the origin. I went right 2, and then I went up 1. Well, if I went right 2 up 1, my base must be b. So the equation for this must be y equals log base 2 of x. Okay. Now, you don't ever have to do that. I'm just trying to show you that's how you graph it. Okay. Everybody in the room look at the graph and shout out. Tell me what the domain is, you guys. X is greater than 0. Yeah, x is greater than 0. You could also say 0 to infinity, both close with parentheses. Okay, look at the range. Range is y. Start low, move up. Everybody tell me the range. All real numbers. Good. The x-intercept of a parent log is always going to be the same, and that is 1, 0. Okay, so we already talked about the fact that log base e, did we talk about this? That log base e is exactly the same as ln. Did we talk about that last time? Okay, it's just in the notes twice. So log base e can be completely replaced with ln. Look what people do. Watch this. People will say ln base e of x, like y equals. That person's super confused. And ln does not have a base. It's just ln. If you wrote it as a log, it would be log base e, but ln doesn't have a base. Who says I gotcha? Okay, good. Okay, let's do this right here. Y equals log base 2 of x. Okay. Everybody in the room, is it a parent, yes or no?
Yes.
Yes, it is. So let's write down the word parent. And log begins with an L, which is vertical. So I remember, oh yeah, I've got that vertical asymptote. I'm telling you right now, do the asymptote first. It's so much easier. And then look, guys, watch how easy. Hits the point 0, 1. Let's change this equation. Let's make it log base 3 so it doesn't match exactly the same graph we just had. So my base is a 3. So I'm going to put my pencil at the origin, and then I'm going to go right 3, and then I'm going to go up 1, and there's my graph. That's it. That easy. Okay? Now, the table is so silly. The table is supposed to help you graph, but we just graphed without the table, okay? I want everybody in the room to write down y equals log base 3 of x. That's what that equation is. If you have a table that you have to fill in, it's so much easier if you convert that. So everybody go 3 to the y is equal to x. And now we can fill in the table, guys. If y is a 0, 3 to the 0 is a 1. If y is a 1, 3 to the first is a 3. If y is a 2, 3 to the second is a 9. If y is a negative 1, what is 3 to the negative first, everybody? 1/3 is correct, okay? Those are all points on the graph. I didn't need it. I already had it graphed, okay? Okay, everybody write down y equals log base e of x. That is exactly the same thing as ln x. Everybody in the room, is that a parent, yes or no?
Yes.
Yes, so write down the word parent. And since it's a parent, I have an asymptote right there. I know it's going to hit 0, 1. I go back to the origin. Guys, tell me how far I go right before I go up 1. 2.7. So I'm going to go right 2.7, up 1, curve it in. There's my graph. Done. Let's fill in the silly table. Convert it. E to the y is equal to x. If y is a 0, e to the 0 is a 1. If y is a 1, e to the first is an e. If y is a negative 1, what is e to the negative first, everybody? 1 over e, and that's sufficient for me. Okay? All right, now we're going to start adjusting it. Okay? So here's your graph. Have we done any that have been highlighted for the final yet? Say which one? This one. Okay, I was wondering. Okay, so this is super, super important, what I'm about to say. If you do this problem in the wrong order, it's going to be like way harder, 10 times harder, okay? So I want you to circle this, and circle this, and circle this, and I want you to write the word skip on each of them. What I want you to do, guys, is I want you to graph it, and then use the graph to find the domain and the intercepts and the asymptotes. It's so much easier, okay? Everybody write down y equals log base 3 of x. That's the parent. If you take out the -1 and the -2, those are the adjustments, then the parent is what remains. So it's just the base, and then it's always just going to be an x. Okay, what do I want you to draw? First thing, always on your graph, always, asymptote. It's right there, right? And then it hits 1, 0, back to the origin, right 3, up 1, curve it in, and we're good. Now let's do the adjustments, and we can do the adjustments all in one step. Everybody tell me, what does the -2 do to my graph? Down 2, because it's on the outside. Talk to me about the -1, everybody. What does that do? Right 1. It's the opposite of what you think. Does moving a vertical asymptote down 2 change the asymptote? No. Does it moving it right 1 change it? Yes. So let's get that asymptote in place. Now, just like the exponentials, guys, look. See how that hits 1, 0? Come to your new graph, go to 1, 0, go down 2, right 1, there's your point. Go to 3, 1, and then go down 2, right 1, there's your point, curve it in. Remember last time I saw you, I talked about the stretch between those 2 points on my graph. So whenever I grade your tests, I always go, this is up 1, right 2, and they did up 1, right 2, so I'm feeling like they did it right. So I'm always just eyeball that stretch, okay? Now let's go back to A. Look how much easier it is if you look at that second graph. Everybody in the room, tell me what the domain of that graph is. X is greater than 1. Yep. Oh, they want it in interval notation, actually. So that would be 1 to infinity. So be careful, okay? Find all the intercepts. You know when they ask it like that I expect you to go x-intercept and y-intercept, okay? Everybody in the room, tell me what the y-intercept is. There is none. Okay. To find the x-intercept, you have to let y be a 0, okay? You know what I'm going to do? This is 3, 1, and this would be 9, 2. So I'm going to go b squared. I'm going to come back up here. I'm just going to give you this. And if this doesn't make sense to you, then don't worry. I want you to go right here, a third point, b squared 2. So that would be, on that problem, it would be 4, 2. So if I went to the origin, I'd go right 4 up 2. That's another point. So if you can remember that, which you totally don't have to, it would save you a lot of work here. So on this problem, my base is a 3, right? So from the origin, so I would go, let me think about this. This right here, from the original, it'd be b squared, which is 9. So if I went 1, 2, 3, 4, 5, I know this is kind of crazy, 6, 7, 8, 9, that's how far I'd have to go out, right? So then I take that 0.9, which I know this is crazy because I'm way off. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 2. And then I go down 2 and to the right 1, and that helps me figure that out. So I can actually figure that out. I know that was kind of rough. So anyway, that ordered pair is 10, 0. Okay. I don't even know if I would do it that way, to be honest with you. So now we know it's 10, 0, so let's fill it in. What I'm going to do is I'm actually going to do it the other way as well. Okay, so go to that equation, and you have to let y be a 0. So everybody write this with me. 0 equals log base 3 of x minus 1 minus 2. If you don't understand what I'm about to do, don't worry. Okay, because we're going to do it next time. But I think most of you can do it. If I'm trying to solve this for if I'm trying to solve this for x, I have to get my log alone. So the first thing I'm going to do is move my 2 over. So then I have log base 3 of x minus 1 equals 2. And now I'm stuck because the only thing I have on the left-hand side is the log. And when I'm stuck, what do? I convert it. Some people might say, well, you've got the -1. Well, yeah, you've got a -1, but it's embedded in the log. It's part of the log. So now I convert it. So I get 3 to the second equals x minus 1. That gives me x minus 1 equals 9. Pull my 1 over, and I get x equals 10. So I got the same thing either way, okay? Who says I followed one or the other, or maybe both of those, okay? And like I said, if you didn't, it's okay, because it's coming. Okay, find the asymptote. That's the red graph that crosses the x-axis at 1. You have to have the x equals with it, okay? Okay, question 7. Is 7 highlighted? No. Okay. So circle A, B, and C, and I want you to write skip. Because if these things are clean, it's so easy to get it off your graph. Okay? Everybody write y equals negative ln of x minus 1 plus 4. There's my equation. It looks nicer because I pulled my 4 over. So the first thing I always want you to do is to graph the parent, which is y equals negative ln x. Is an ln a log? Tell me that. Yes, it is. It's a log base e, right? And a log has an asymptote right there. Remember, it hits the point 1, 0. I go back to the origin, not to that dot. How far do I go right before I go up 1, everybody? 2.7. So I go right 2.7, up 1, and there's my graph. Okay, listen what I want you to do. I want you by yourself, because I want you to know if you understand. I want you to come over here to the side, and I want you to list the 3 transformations off that graph. Go ahead. I'm going to give you like 15 seconds to do that. Do we get out at 06 or 04, right? Okay. Okay, everybody in the room, plus 4. Tell me what that does. Up 4. Minus 1, what's that? Right 1. And then the negative in the front, it's obviously a reflection. Is that x or y? X. Okay. If you cannot answer this question, I'm not trying to be dramatic, I'm just being real. I've gone through so many hours of grading workshops at Weber. If you cannot answer this question, you will miss every point on this problem on the final. And I think it's probably a 15-pointer. It's going to be so painful. This one little question. And here's the question. Does anybody know what I'm going to ask you? What do you do first? That's exactly right. Anticipating my questions is so good. Because then when you do it, you're questioning yourself in your mind. Yes. Answer the question. What do you do first, guys? What must you do first? The reflection. Yes. Okay, so take that guy. It does not change the asymptote because the top goes to the bottom and the bottom goes to the top. It does not change the 1, 0. Now the 2.71 is going to be 2.7 comma negative 1, and it's going to curve like that. Then I take that guy and I go up 4 and right 1. Up 4 does not change the asymptote, but right 1 does change it. Okay, so everybody put your pencil on 1, 0, and then go up 4, 1, 2, 3, 4, right 1. There's that point. This one's kind of awkward because it's 2.7. So go 2.7, negative 1, up 4, 1, 2, 3, 4, right 1. And you can check that stretch, guys. Look, 1 and a 1.7 is what it is. 1, 1.7. Do I still have the same stretch? Yep, so I know I didn't mess up. Oops, that probably is a little too flat. So it's going to look about like this, or not flat enough, actually. Looks like that. Okay, who says I'm good? I get this. Do a big raise up. Let me see. Okay, good. Let's go back. Find the domain. Interval notation. What's the smallest x I'm going to list? Talk to me.
0.
Not a 0. Look at the final graph. What is it, guys? It's a 1, right? And does it touch the 1?
No.
No, you guys are kind of killing me today. Nobody's answering me. Does it touch the 1, guys?
No.
No. How far does it go? Infinity. So this is 1 to infinity. Intercepts, everybody go x-intercept, y-intercept. Everybody in the room, 35 people, what's the y-intercept?
None.
There's none. What's the x-intercept? It's not going to be clean. So let's let y be a 0. And everybody go 0 equals negative. I'm going to write log base e of x minus 1 plus 4. The reason I'm going to write log base e, because I think you're going to be better at converting it if it says log base e. If you don't understand what I'm about to do, it's okay. It's okay. Just do your best and know we're going to clean it up. Tell me my first step. What do I do here? Get the log alone, right? So move your 4. So now I have negative log base e. Actually, you know what I'm going to do? I'm going to move my log. So split those apart. So I'm going to go log base e of x minus 1 equals 4. That way my log is a positive, right? And now I'm already stuck. So when you're stuck, you convert. So this is e to the 4th is equal to x minus 1. Pull the 1 over, and you get x equals 1 plus e to the 4th. Okay? Like I said, like 6 times, if that confuses you, don't worry, because you'll get there. 1 plus e to the 4th. Okay? Find all the asymptotes. We only have one. It's the red final asymptote. It hits the x-axis at 1. That's it. Who says I'm good? Raise your hand. Let me see how you're feeling. Okay, great. Okay, example 8. Boy, I better pick it up. Okay, example 8, piecewise. Everybody write down y equals log base e of x. I like to write it as log base e because I think it's easier for you to visualize, okay? So take your pencil, dash that asymptote. It hits the 0.10, pencil at the origin, 2.7, up 1, curve it in, and it looks like that, okay? And I'm actually going to, oh yeah, we're good. That's if x is less than or equal to 1. So here's my 1. The less than is to the left, so I've got to get rid of everything to the right of a 1. So I'm getting rid of all that stuff, okay? And I do have an equal sign, so that is going to be closed like that, okay? Okay, let's do the next one. Y equals negative ln x. So guys, I am very, very, very visual. I have got to see that, or I started getting kind of freaked out. Okay, so there's my parent. I want to see my parent. That's how my brain works. Now I'm going to take that parent, I'm going to reflect it across the x-axis. So when I do, it's going to go like this. This part's going to be up, and that 2.71 is going to be 2.7 comma negative 1, like that. Okay, but that whole graph is not supposed to be there, only where x is bigger than 1. So that would be to the right. So I'm going to get rid of the left. So that's gone. Now that circle would be opened, but I already had it closed, and we remember when an open intersects with a closed, it's closed. So there's your graph. Okay, all right, right here. Find the domain. Any more of these highlighted? I think 9 or 10 isn't it? No? Any more highlighted beyond that? Nothing? Okay. Okay, everybody write this down. Y equals log base A of B. So here are the restrictions. A has to be greater than 1. And B has to be greater than 0. You can't take the log of 0. The log of 0 is an error. Okay, so if you look at that, the 7's fine. You guys, they're never going to give you like an X in there. I can just promise you. So the fact that A has to be greater than 0 or greater than 1, I don't think is ever going to be something you have to remember. But I do need you to remember that that guy right there in green has to be greater than 0. So it's super easy. Just say 4x minus 1 has to be greater than, or minus 5 has to be greater than 0. So 4x has to be greater than 5. So x has to be greater than 5/4. Now, sometimes they trick you and they say, what is the interval? So you just have to be careful. If they say that, it's 5/4 with the parenthesis to infinity, like that. Okay? Okay, let's do another one. So again, that inside stuff has to be greater than 0. So it's very simple. You just have to remember 3x minus 1 must be greater than 0. 3x must be greater than 1. X has to be greater than 1/3, and we'll just leave it like that. Okay? Now, question 11. Question 11, I don't think is going to happen, okay? I stuck it on here because I think it may have happened like 8 years ago, like a long time ago. Do I think it's going to happen to you? No. But what if it does? So I'm going to show you just so you have it, just so you have seen it, okay? So the 3 is fine. What we're taking the log of, all this stuff right here, I know has to be greater than 0. So everybody go, x minus 1 over x to the second plus 4x must be greater than 0. What do we do now? What kind of a problem is this, everybody? It is a critical numbers type what? Type 2. So step 1, get a 0 done. Step 2, get a common denominator, not necessary. Step number 3, factor. So on the bottom, I'm going to take out an x and I'm left with x plus 4. What do I do after that, everybody? List your critical numbers, correct, which are 1, 0, and negative 4. I don't have an equal sign in my inequality, so I don't have to worry about restrictions. They're all going to be open circles anyway. So the negative 4 goes over here. The 0 is quite a ways away. The 1 is pretty close to the 0. My circles are all going to be opened. You guys, all the exponents are 1s, so I know my signs will alternate. Let me show you this little trick right here. You guys are so smart. I know you can handle this. I can't test a 0. Never mind. I'll show you the trick later. So I'm still going to show you the trick. Look right here. I'm going to choose an easy reason to test, like over there. So that would be a 2. Okay, watch this. I'm not even going to use my calculator. If I go 2 minus 1, I get a positive number. If I put a 2 there, I get a positive number. If I put a 2 there, I get a positive number. 3 positives gives me a positive. So I know that region is a positive. So this is positive, negative, positive, negative. I'm looking for where it's greater than 0. That would be the positive, so that would be there. So my answer is negative 4 to 0 with the parenthesis, union 1 to infinity. That's my answer. Okay. All right. Here we go. Question A. Those last two are pretty easy. Okay, step number 1, isolate it. Step number 2, convert it. Step number 3, solve. Step number 4, if the original is a log, you must check. Okay, here we go. This right here is all one thing. Look, you've got your log. The base is intertwined in the log, as is the 4x minus 7. Some people do this, guys, look. Divide by 3. That's craziness because the 3 is part of it. Some people will divide by 4 or subtract 7. Those are all crazy because it's all stuck together. Who says I understand that? I can see that. Okay, so when you get stuck, now we're down to step 2, you convert it. So you convert it into exponential. So everybody go 3 raised to the other side, which is a 2, is equal to 4x minus 7. Well, now it's easy. You just solve that. So now you just have 4x minus 7 is equal to 9. The 7 comes over, 4x equals 16. Divide by 4, and you get x equals 4. Now, if it's given in log form, you have to check it because sometimes it doesn't work. So everybody go like this. Log base 3 of 4 times 4 minus 7 equals 2. Okay, now I have to tell you something else. I feel like I need to look at reordering these lessons. I feel kind of bad. Okay, everybody write down log base 2 of 3. If you're trying to evaluate log base 2 of 3 on your calculator, all you do is go log 3 divided by log 2. It's important that you know that. If the base is not 10, you take the log of the big number divided by the log of the base, okay? So apply that over here, okay? So this is going to be log base 3 of 4 times 4 is 16. Subtract 7 is 9. Everybody grab your calculator. I'm going to show you how to put that left side in. Okay, so the way you put the left side in is you go log 9, close it off, divided by log 3, close it off, hit enter. Did I get a 2? Yes. So everything checked out, and now I walk away 100% confident that that is the correct answer. Okay, raise your hand if you're with me. Do a big raise up. Okay, let's keep going. We are stuck. It's isolated, so we convert it. So it's x to the second is equal to 64. And now I square root, and I get x equals, guys, what comes right after the equals? Plus or minus 8. And now I have to write the word check. If you don't write the word check, I'm not giving you credit for the check. Okay? So if I'm checking two things, I want you to go x equals 8. And then I want you to go log base 8 of 64 is equal to 2. Let's check it. So grab your calculator and go log 64, close it off, divided by log 8, close it off, hit enter, and I got a 2, so it checks out fine. Now I'm going to put x equals negative 8. So I'm going to go log base negative 8 of 64 is equal to 2. Talk to me about that. You can't have a negative. It has to be greater than 1. So I'm going to say invalid solution. So my answer is x equals 8, and I'm done. Okay, question E. Isolate the exponential. You guys look, this is all one thing. Here's your base. All of that is stuck in the exponent. Please don't subtract 1. Please don't divide by negative 2. They're all one thing. Your brain should see y equals 13 because it's all stuck. Okay, since we're stuck, we convert it. So it's log base E of 13. What's log base E? ln. Yep, so let's go ln 13 equals negative 2x plus 1. Pull the 1 over and it becomes a negative. So now I have negative 2x equals ln 13 minus 1. Okay, I want you to look at that, and I want everybody to freeze. I do not recommend you write it like that, because I think you're going to write ln 12. The 13 is part of the ln. The negative 1 is completely separate. It's like y minus 1. So don't combine those. And to prevent yourself from combining those, I would actually write negative 1 plus ln 13. It's the same thing instead of ln 13 minus 1. Now to solve for x, you divide by a negative 2. So you have negative 1 plus ln 13 divided by negative 2. There's your answer. Okay, let's go to D. Everybody in the room tell me, is the log isolated, yes or no? Yes. Yes, it is. So as soon as you're isolated, as soon as you're stuck, you convert it. So you write it as y to the negative third is 1 over 27. Now I've got that negative exponent, which I don't love, right? So there's so many different ways to do this. I'm going to write this as 1 over y to the third is 1 over 27. So all I did is bring that y to the third down. Okay. Now I'm really going to think about it. So 1 over y to the third would then be equal to 1 over what to the third? Can you tell me that? It's a 3, right? Therefore, y must be 3. Okay. Now, do I have to check that problem? I do, since it's given in log. So everybody write the word check, and then I want you to just write log base 3 of 1 over 27 equals negative 3. Now grab your calculator, and let's make sure you know how to put that in. So you go log 1 divide 27, close it off, divided by log 3, close it off, hit enter, and I got negative 3 equals negative 3. Really, right there, guys, you should write negative 3 equals negative 3, so I know you checked it. Okay, let's do E. Are we stuck? Everybody tell me that. Yes, we are. As soon as you're stuck, everybody in the room, 35 people, what do? Convert it. So everybody go 9 to the negative 1/2 is equal to y. What do you think we need to take care of first? The negative. So everybody write y equals 1 over 9 to the 1/2. So I brought it down. I'm surprised that you couldn't answer this question last time. If you have 9 to the 1/2, that's the same thing as what, everybody? The square root. So now you're answering. But I had the same question last time and you guys didn't know. The square root of 9 is a 3. So that's it. Why didn't I do plus or minus? It was already there. That's exact answer. That's exactly perfect. I didn't make the square root. The 1/2 was in the problem to begin with, so I didn't make it. So that's why you don't do plus or minus. Okay, question F. Are we stuck? Everybody tell me.
Do we not have to check that one?
We do have to check it. Thank you. I'm getting too ahead of myself. Write down check. Actually, I want to say something. Freeze right here because I kind of glossed over it. Look at this question right here. My thing is taking a second to catch up. Look right there. I didn't check C. And we didn't even talk about why I didn't check it. Do you have to check it? Why not? Wasn't given in log. Good. Okay, now let's go back over here and let's check it. Thank you for reminding me. Okay, so everybody go log base 9 of 1/3 is equal to negative 1/2. Put it in your calculator and see if you can get it. See if you can do it by yourself without me telling you what buttons to push. Do you get a negative 1/2? Yes. Okay. If you didn't get a negative 1/2, let me help you. Okay. After the lesson. Okay. Right here we're stuck. So we convert it. Log base what? There's nothing there. 10. So 10 to the first is equal to x minus 1 over x. Okay, listen what we're going to do. If you're not, I'm so glad today's homeroom. So if you're not in my homeroom, go ahead and go. And I'm just going to keep going and then I'll upload so you can finish at home. Everybody that's in my homeroom, we're just rolling on. Okay, I'll let you go to the bathroom in a second. Okay, 10 to the first is just a 10, right? So tell me what to do right here. What do we do?
Ethan Rawlings, can you please
What do we do? Cross multiply. Put a 1 underneath and cross multiply. 10 times x is 10x. 1 times x minus 1 is x minus 1. Pull the x over, it becomes a negative. So you have 9x equals negative 1. Divide by 9, x equals negative 1/9. Okay, now I have to check it. The check on this is kind of tough. So everybody go the log of negative 1/9 minus 1 over negative 1/9 equals 1. Now, listen, okay? When you put this in, you have to add parentheses around the top and the bottom. Okay, so here we go. Let's do it together. Everybody go log. Notice there's already a parenthesis that pops up. That's this guy. So that parenthesis came there automatically. So now I have to do the red parenthesis on the top. So I'm going to go parenthesis, negative 1 divide 9 minus 1 close parenthesis divided by parenthesis, negative 1 divide 9 close parenthesis, enter, and I got a 1. So this is 1 equals 1, and I know I'm good. Okay, all right, let's keep going. This is easy. We're basically done. Well, not true. 13's easy. Okay, chemists use the pH scale to test acidity. So there's your equation. Seawater has a pH of H.5. Find the hydrogen ion concentration. So the hydrogen ion, you guys, is the H+. So this 8.5 is your pH. So everybody go 8.5 equals negative log of H+. I'm dropping the brackets because I don't think it's necessary. Don't let the plus freak you out. Like H+ is just like an X. It could say negative 8.5 minus log of X. It's not scary. Am I stuck? Is my log alone right now, everybody? It is not alone. What's there that shouldn't be? The negative. So let's change the signs. So you have the log of H+ is negative 8.5. And now I'm stuck. So that's log base 10. So when I convert it, it's 10 to the negative 8.5 is equal to H+. Let's get a decimal for that. So everybody go 10 to the negative 8.5 hit enter, and it's a terrible decimal. I lied. We're just going to leave it. It's got like a ton of zeros in the front. So we're going to just leave it. Okay, question 14, and then we're done. The normal healing of wounds can be modeled by this equation. A sub 0 is in the original area of the wound, and it originally has 100 square millimeters. This is the same equation we used last time. So everybody go A equals 100 E to the negative 0.35 times N. And then I want you to remember that N stands for days, and that A stands for the area, okay? After how many days will the wound be half of its original size? Okay, this is important, so look. After how many days? So that's what I'm looking for. So I know I'm not going to change my N. My N is going to stay in N. I have to put a new number in on the other side. So if the wound starts at 100 square millimeters, somebody tell me what I put on the other side.
50.
It's 50. How do you know 50? Half of the original size. Yeah. Everybody in the room tell me this. Am I stuck? Is my exponent, my base and my exponent alone? Tell me.
No.
It's not. What's there? The 100. So I divide by 100, and I have E to the negative 3.5 N is equal to 50 over 100, which is 0.5. I can totally write that as 0.5. Now is my exponential alone, my base and my exponent. Tell me, guys.
Yes.
Yes, so I'm stuck, and when I'm stuck, what do I do? Convert it. So then it's going to be log base E of 0.5, that's ln 0.5, is negative 0.35 N. To solve for N, I divide by negative 0.35, so I get N equals, okay, grab your calculator, and go ln 0.5, close it up, divided by negative 0.35, hit enter, and I get, we're going to go to 2 digits, and that would not be something you decide. That's given in the directions. It's 1.98 days. Don't clear your calculator. Is this problem checkable? Tell me that. Yes or no? Can I check it?
Yes.
Whenever you solve, you can always check it. Why don't I want you to clear it right now?
Because
You're going to store it. Everybody hit store, enter. And then I want you to come over here to the right-hand side. I want you to plug that in. Where I see N, I'm going to hit membar, and I better get 50. So everybody go 100 second ln negative 0.35 membar, enter, close it, enter, bam. I just checked it. So I plugged it back in and I got a 50. Okay? Okay, last question. How long until it's 10% of its original size? Okay, so how long? So I know I'm solving for the number of days. And somebody tell me what I put on the other side. A 10. Okay, now I'm going to pause for a second, let you catch up. Don't go ahead of me, but just let's pause and get a couple people caught up. I want to ask you a question. Raise your hands if you understood part A. Who understood part A? Who did not understand part A? Let me see this. Okay, good. Because B is going to be just like A. So if you understand, if you're confused on A, but you follow me through B, then I fixed you. Okay. What do I do? Yes, honey.
Why did you write 10 and not 0.10?
Because if I have $100, 10% is $10. Yeah. Okay. Tell me what to do right here. Everybody tell me. Divide by 100. So I have E to the negative 0.35 N equals, there comes my 0.1, sweetie, when I go 100 divided by, or 10 divided by 100. Tell me what to do now, everybody. You convert it because we're stuck. So it's log base E of 0.1, that's ln 0.1 is equal to negative 0.35 N, and now to get the N alone, it's ln 0.1 divided by negative 0.35. Grab your calculator and go ln 0.1, close it off, divided by negative 0.35, hit enter. We're going to say they said to round to 3 digits, and that would be 6.579. They're asking how long I have to have a label, and my label's days. If you want to check it, store it, plug it there, and you better get a 10. You can check it in less than 30 seconds for sure. Okay? Okay, that's it. So sorry that was so long. I feel a little bit bad. Like, I feel like me